All right, hello and welcome back, ALEKS students. So this is an ALEKS topic that's called writing Lewis structures for a molecule with one central atom and no octet rule exceptions. And basically all that is telling us just from the very beginning is that we do not need to worry about anything with an expanded octet. So everything in our molecule, all of the different atoms are going to obey the octet rule. Nothing's going to have 10 or 12 valence electrons around it. It's just going to be, following the octet rule. So definitely a good thing to keep in mind. Now, as we jump into this, there are a good set of rules or sort of a set steps process that we should go through. And it's really easy to get in bad habits and skip over the first step of the process. So I'm going to try to reinforce that for you today by going through these steps. So the first step is to count the valence electrons. And like I said, this is the step that a lot of students, a lot of folks skip over. And if you do that, then you're much more likely to make a mistake later on. So step 2, don't be lazy and actually do that. Actually count the valence electrons. And then once you've done that, that's a number that we're going to be referring back to as we go through the rest of these steps. So make sure you keep that in mind. Step 3 is to draw the skeletal structure. A lot of folks, again, will start at step 3 and then end up making a mistake. So definitely, if you do start at step 3, always go back and make sure you just double check your valence electrons. Then we're going to fill in the electrons in the outer atoms first. And then lastly, we're going to fill in any remaining electrons in the central atom, which actually would be relevant for this nitrogen trifluoride. So let's go ahead and jump into it. My initial move here was actually just to start drawing the skeletal structure. I'm not paying attention to my own advice, but let's go ahead and pause and actually count the valence electrons. So nitrogen should have 5 valence electrons. Fluorine is a halogen, so we'll have 7 valence electrons, and then we've got 3 of those, so that's 21 plus 5. In our structure then, we should end up with 26 electrons in our picture. So now that we've figured that out, now we're gonna start drawing this molecule. So we're gonna have nitrogen in the center, and then the 3 fluorines are going to be arranged around that central nitrogen. So we'll place the bonds first. Then we can go in and fill in our fluorine atoms like that. And now we can start putting in our electron pairs, right? So we're going to start on the outer atoms here. So this fluorine is going to get 3 lone pairs of electrons to fill the octet, right? So basically what we're doing here is we're just counting up to 8. 2 electrons in the bond, and then 2, 4, 6 electrons is the lone pairs. That gives us 8 electrons around this fluorine. So we'll do the same thing for the other fluorines. And then now we've done all of our outer electrons, outer atoms. Now we'll look at our central, and we're going to put 1 lone pair on that nitrogen because we've got to fill that octet for nitrogen. Now we want to double check. Now we want to go through and count all of these electrons to make sure that we've got that 26 that we said we should have in there, from our valence electron count from step 1 to make sure that we have the right number of electrons. So let's go and do that. So we'll count the bonds first. So 3 bonds, 2 electrons in each bond. So 2, 4, 6. Now our lone pairs, and I like to count just the same way that I added them in. So 2, 4, 6 in our bonds, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, right? So just counting all those electrons, 26 electrons in my picture. I should have 26 electrons in my Lewis dot structure, so this should be right. So let's go ahead and check that. Great. Let's go ahead and do one more just for more practice. So here we've got a water molecule. This one will be very straightforward. Maybe we'll skip this one and do a different one. So I've got the solve button. I'm just going to use that, and then I'll do more practice. Great. So here we've got ammonium NH4+. This will be a really good one. So again, step 1, count the valence electrons. So nitrogen has 5. Each hydrogen has 4, or excuse me, each hydrogen has 1. So 5 plus 4 is 9. And then we've got an ion, right? So this is the first time that we've got an ion, which is really cool. So because we've got a +1 ion, that means that one of the electrons has been removed. So even though we've got 9 from nitrogen plus hydrogen, because it's an ion, we're going to remove one of those electrons. Therefore, in our final picture, we should only have 8 electrons in the picture. So again, step 1, count the valence electrons, really important thing to do there. So I'm going to put nitrogen in the middle, and then I know that the hydrogen is going to be just arranged around that. Each hydrogen really only wants to have 1 bond Really not very many options for us, in terms of different ways to draw this picture. So I'm going to put in my hydrogens then, like this. And now we can sort of pause here and count our valence electron, count our electrons again. So, we said that we should end up with 8 because we've got, 9 minus 1 is 8. That's how we get to this +1 charge. We're removing that electron, removing that negative charge. And then I've got 4 bonds, 2 electrons in each bond, 2, 4, 6, 8. So I've got the right picture. Now I do have one more thing that I need to do that's really important, is I need to add in the charge. I need to indicate that this is a charged species, right? That's sort of the proper way to draw this, the proper way to communicate that. So I'm going to add in that plus charge there. Go ahead and check, and we got it right. So hopefully that gives you an overview of how to go about drawing these Lewis dot structures. I want to reinforce these steps. Count the valence electrons. Don't be lazy. And then also, I've got some hints down here that as you get more experience with this, then you will, they will come in handy. Now, this hint does not actually apply to this specific molecule here because this is an ion. But in general, especially if you're looking at neutral atoms, neutral molecules, you're going to have these patterns that are very common. So carbon typically likes to have 4 bonds. Nitrogen likes to have 3 bonds and 1 lone pair. Of course, we're not seeing that here again, and that's because we've got an ion. That makes it so that these are not always, exactly the rule. These are just good hints, good guidelines to keep in the back of your mind. Oxygen likes to have 2 bonds and 2 lone pairs, and then our halogens like to have 1 bond and 3 lone pairs, which is actually what we saw in the previous example that we did. All right, so hopefully that's helpful, and thanks very much.